This is the second video in the series about AI without jargon, and this particular one is about nature versus nurture, which is obviously jargon. So let's just explain. What that means is, what are we born with? Are we totally unprogrammed when we get born and we learn everything? Or do we have some pre-programming, like understand how balls fall through the air? When we create software trying to emulate this human learning, how much do we predefine and how much do we make the computer learn? So let's take a step back and just review where we got to from the previous video. Basically, we discovered what AI was, that all it is trying to emulate human intelligence as much as possible and potentially exceed it at some stage. And that actually where we are today is we can only produce these narrow AIs, these AIs specific to a task such as playing chess or Go or driving a car. But if you add all the narrow intelligences together, then maybe you start to get this human type intelligence, which is actually called general artificial intelligence. Let's just review also some of the people involved in the area of artificial intelligence research. Artificial intelligence actually began 60 years ago, and there have always been big hopes to make it fantastic and work well. And right at the beginning, they thought that they should try and emulate the way the brain worked. And the brain thought processes are controlled by neurons and the linkages between those neurons. And the idea was that we could have software which emulated the way those neurons worked. But the reality was, it was a lot more difficult than they thought. And it was only in actually 6 years ago, in 2012, that a guy called Geoff Hinton finally began to break through some of these issues that they had. At the same time, computers were becoming much more powerful. And there were these things called GPUs, which are used in games to do very fast graphics that were ideal for the sort of matrix multiplication type of effect that you have in emulating neurons with neural networks. What Geoff Hinton and another guy called Yann LeCun discovered was that you could put layers of neurons together and have inside hidden layers where the processing happened, and do something called back propagation, which allowed layers to feed back information to higher layers. This was the breakthrough, and this is what's enabled modern computer scientists to do things like image recognition and all sorts of pattern recognition in large volumes of data. But today's systems still require lots of training, lots of data, and it's not the answer to all things, but it's a major breakthrough. What we're trying to do now, when we're trying to get to artificial general intelligence, is have effectively another part to the hierarchy, which is that you can, above the pattern recognition software, have a concept layer of software which understands some of the concepts that you're dealing with. Understand what a lion is, that it's part of the cat family, but that interpretation can be learnt, or that classification, without actually telling the computer that that's a big cat or that's a little cat. This idea of a hierarchy and a concept layer was first proposed by Ray Kurzweil, who we'll talk about a lot more in the future. So what's in this concept layer? It's sort of like the brain trying to model the world. And in this model of the world, we do things like we explain and understand what we see, we imagine things we could see, we do problem solving and planning for the future, and we build new models and share our models with others. It all seems a bit complicated really, but I think a better way of looking at it is it's a bit like a computer simulation. Inside our brains we are simulating the world. And a good example of a simulation is like a game. Any old game where people have characters and then there are events taking place, like shooting someone or killing someone. These games are our interpretation of what the real world is. But let's get back to understanding what we're born with, nature versus nurture. When a baby is born, it is fairly helpless. It can hardly see, it certainly can't focus its eyes. But within 4 months, it has this understanding of what an object is, what space is, and whether something is firm or soft. At 6 to 7 months, it has the concept of some inertia, whether once things start moving, they continue moving. That's from playing with bricks and so on. By 8 to 10 months, it understands gravity, weight, the shape of objects. And 10 to 12 months, it begins to understand weight, mass, shape, consistency, object tracking. And that's why at that point, babies start to stand and move around. So you can see from that babies learn a lot in the first few months. Therefore, they're probably not born with too much predisposed learning. But the tasks they go through in those first, say, 12 months, the learning tasks are so great that the thoughts are there is some predisposed understanding that is built into the brain. And then the question is, the software that we're building for AI, do we try to build in some existing concepts, such as a model of gravity and movement, momentum, and so on? Just like when you build a game, you often use a games engine which has all these features already built in to make the life easier for a programmer. So a baby is effectively learning how to learn at the very beginning. And you can see here a baby playing with bricks is actually playing to learn how things work. He will knock them over, he'll try things, he'll explore the boundaries effectively of the physics, of the model that he's creating in his brain. This learning how to learn is actually called meta-learning, which is just a bit of jargon. And the experience of exploring all the boundaries is called self-play. So the conclusion is that babies probably are born with some concepts already built into their brains, but there's a hell of a lot that's actually learned, and the babies actually learn to learn. Now, whether or not computer programs should work the same way is a big question. It might be easier to try and pre-program some of the capabilities, such as the physics of how a ball falls or how a brick falls over when it gets too high. There's a lot here that's not fully understood yet, but the reality is that this understanding is being worked on by thousands of scientists all over the world, and it might well be solved within the next 10 years, and we end up with something quite intelligent that can learn and have been pre-programmed with some of the capabilities that it needs to know about to think like a human. So the question was how much is nature and how much is nurture? How much are we pre-programmed with? The reality is it probably doesn't matter. We can cheat, because in any case a neural network is just an approximation to what's really going on in the brain. Anyway, that's it for this week. Please subscribe to the YouTube channel, and if you want, go to this Patreon link on the screen where you can help us fund these videos. Many thanks from Ollie and myself. See you next week.